Have you ever looked up at the night sky, at that vast velvet blackness dotted with countless stars, and asked yourself the simplest yet most profound question of all? Why is there something rather than nothing? It is a question that has haunted thinkers, poets, and every curious human mind since we first became aware of our own existence. It's not just about how the stars formed, or how planets came to be. It goes deeper. It asks about the very fabric of reality itself. Why does this grand, magnificent, and often bewildering cosmos exist at all? It seems almost absurd that anything should exist. And yet here we are. We are collections of stardust, living on a small, wet rock orbiting an ordinary star, contemplating it all. This profound question is not a modern invention. It is as old as humanity itself. Imagine our ancient ancestors, gathered around a crackling fire, the darkness pressing in on all sides. Above them, the same canopy of stars we see today would have wheeled across the sky. Without the light pollution of our cities, their view would have been infinitely more brilliant. For them, the sky was not just a beautiful backdrop. It was a source of awe, mystery, and perhaps even fear. They would have seen the regular procession of the sun and moon, the strange wandering of the planets, and the sudden fiery streak of a meteor. These celestial events were the first great mysteries that captured the human imagination. They were patterns in the chaos, rhythms in the vastness of the world. Why does the sun rise every morning, bringing warmth and light? Why does the moon wax and wane in a predictable cycle? These were not scientific questions as we understand them now, but they were born from the same fundamental human trait: curiosity. This relentless desire to understand our surroundings is the engine that has driven all our progress, from the first stone tools to the launch of space telescopes. The earliest records, from cave paintings to ancient carvings, are filled with symbols that reflect this cosmic curiosity. They remind us our curiosity links us to every human who has ever wondered. Long before we had the language of mathematics and physics, we had the language of myth. Every ancient culture developed its own creation stories, magnificent tales that sought to explain where everything came from. These myths were our first scientific theories. They were our first cosmological models, imaginative attempts to impose order on a seemingly chaotic universe. From the Babylonian Enuma Elish, a universe born from the conflict of primordial gods, to the Norse sagas of a cosmos emerging from the body of a giant, these stories provided a framework for understanding existence. More than explanations, they were woven into society. They supplied moral and social order, telling people who they were and how they should live. The Egyptian story of the sky goddess Nut and earth god Geb explained the sky and the earth and reflected a worldview of balance. It reflected balance and duality at the heart of their cosmos. These myths were humanity's first grand unified theories, blending the physical and the metaphysical into a single narrative. They explain the heavens and the laws as they perceived them. What is remarkable is the shared sense of wonder across cultures. Though details differ, the theme is often creation from chaos or nothingness. Genesis speaks of a formless void. Hindu cosmology imagines cyclical creation. Both grapple with non-existence to existence. These tales face the same concept modern physicists study: how non-existence became existence. As our tools became more powerful, our story of creation began to change. In the 20th century, we made a discovery that altered our understanding. Astronomers like Edwin Hubble noticed something incredible. Distant galaxies were all moving away from us, and the farther away, the faster they recede. This observation meant the universe is expanding. Rewind the clock, and everything compresses into an unimaginably hot, dense state. This is the core idea of the Big Bang Theory. It is not an explosion in space, but an expansion of space itself. Around 13.8 billion years ago, the observable universe began its expansion. In the first fractions of a second, the fundamental forces separated and elementary particles formed. It was a period of unimaginable energy and transformation. Within minutes, protons and neutrons formed the nuclei of hydrogen and helium. After about 380,000 years, the universe cooled, electrons joined nuclei, and the cosmos became transparent. The cosmic microwave background is the oldest light. We can still detect it today. The Big Bang Theory is supported by expansion, element abundances, and this faint afterglow. It traces our history from that initial moment to everything we see now. The Big Bang gives a powerful account of how, but it does not directly address why. This is where science and philosophy intersect. Science works by creating testable hypotheses that make predictions which can be verified or falsified. By experiment and observation, we build reliable models. Philosophy ventures beyond empirical testing, probing the nature of existence itself. Thinkers like Leibniz proposed the principle of sufficient reason, that anything which exists must have a reason or cause. Applied to the universe, this asks, what was the reason for the Big Bang? What, if anything, came before or caused it? Right now, science can't answer these. Our laws break down at the singularity. But science and philosophy are not in conflict. They complement one another. Science provides the laws of nature, the history of the cosmos, and the ingredients of reality. Philosophy uses that to probe meaning, purpose, and ultimate cause. A philosopher might ask, if the laws brought the universe into being, why are they the way they are? Science can describe laws precisely, but not necessarily why they permit stars, planets, and life. As science advances, it may probe before the Big Bang, and for every answer, philosophy will ask a deeper question. Thus, we are pushed toward the horizon of understanding. As we push cosmology's boundaries, we encounter ideas that are mind-bending and speculative. One of the most intriguing is the multiverse hypothesis. Imagine our universe as a bubble among countless others in a cosmic ocean. Each bubble could have its own laws, constants, and dimensions. One version, eternal inflation, suggests inflation may be continuous, creating many bubble universes. Different regions stop inflating at different times, pinching off into separate universes. Another route is quantum mechanics. The many worlds interpretation suggests every quantum measurement creates branches. Flip a coin. In one universe it lands heads, in another tails. Every quantum event could create near-infinite parallel worlds. There might be universes where dinosaurs persisted or where you made different choices. These ideas sit at the edge of theoretical physics and are hard to test directly. We are, in a sense, trapped inside our own bubble. Scientists look for indirect evidence, strange patterns or bruises in the cosmic microwave background, like a scar in the CMB that could indicate a collision with another universe. Whether real or not, the multiverse reframes the question, instead of why this universe? We ask, why not this universe? It offers a potential answer to why our universe seems so special. When we examine the laws of physics that govern our universe, we find something remarkable. The fundamental constants, the strength of gravity, the mass of the electron, the charge of the proton, appear exquisitely fine-tuned for life. If gravity were slightly stronger, stars would burn too fast. Slightly weaker, and stars might never form. This astonishing precision is called the fine-tuning problem. There are different ways to think about this. One perspective sees it as evidence of a creator or purpose, deliberate design. Another uses the multiverse. With countless universes, ours is simply one where conditions permit life. This is the anthropic principle. We observe this universe because only such universes can host observers. A third possibility, a deeper law of physics that dictates these values as inevitable. If true, fine-tuning is an illusion born of incomplete knowledge. Finding such a theory is one of modern physics' great goals. It would provide a single elegant explanation for reality's structure. In that case, the need for a designer or a multiverse might vanish. The constants would be necessary, not contingent. The search continues. Whether anthropics, multiverse, creator, or deeper law, each offers a different picture. All remind us how little we still know and how wondrous the mystery remains. What is it about the human spirit that drives us to ask enormous questions? Why build experiments like the LHC or launch telescopes into deep space? To probe the smallest particles and gaze at the earliest moments of time. Each tool peels back another layer of reality. This insatiable curiosity is the engine of civilization and the essence of being human. It drives us to push technology and thinking. From Greek geometry to the invention of the telescope, curiosity reshaped our worldview. Today we build detectors to sense ripples in space-time itself. Each new tool reveals a stranger, more wonderful universe. The journey is as important as the destination. Curiosity isn't just facts. It builds technology and enriches life. It gives us a sense of awe, knowing our atoms were forged in dying stars. That realization links us to the cosmos and makes us part of its story. It is humbling and profoundly comforting. From voyages across oceans to missions to the moon, curiosity drives exploration to the universe itself. We look out at the cosmic ocean and set our sights on the farthest shores of knowledge. So we return to where we began. We began as storytellers, became philosophers, then scientists, each step widening our view. From cosmic fire to the atoms of our bodies, we are part of that unfolding story. There are multiple ways to answer why the universe exists: design, multiverse chance, or deeper necessities of physics. Each view carries different meanings for us. What matters is that we keep asking, keep exploring, and keep marveling. Our curiosity is the engine of progress and the source of our deepest joys. You too are part of this story. Look up, wonder, and join the search. We are not separate from the cosmos. We are the cosmos aware of itself. That realization is at once humbling and empowering. It reminds us that we belong. Keep asking, keep wondering. Thank you for joining the journey.